In this video, we're going to go over how to solve equations with radicals. We're going to see some examples that are going to look like the three equations that are on your screen here, and our goal is to solve these equations, find values of x to make these things true. Before we get into the nuts and bolts of how to solve equations like this, I'm going to go over a very useful shortcut that's going to save us some time. So if you need to square a binomial, a common mistake would be to do this. Now, this is not correct. I'm going to write not equals, and I'm going to write it in red because it's wrong. A common mistake would just be to say, oh, I'll square the x, and I'll square this 2 here, and I get x squared plus 4. Now, that is not correct. That's part of the answer, but it's not the full answer. Okay, so how do you actually square a binomial? You can always write it out twice and FOIL it, but that's a couple steps, and you can do it in one step if you know this simple shortcut. You're always going to end up with 3 terms. The first term will always be the square of your first term. My first term is x, so I square that and I get x squared. The last term will always be the square of term 2, your second term. It's 2 in this case. When I square that, I get a positive 4. Now your middle term, to find this, you're going to multiply 2 times your first term times your last term. So when I'm doing my middle term here, I'm going to take 2 times my first term, which was x, times my last term, which is going to give me 4x, in fact, positive 4x. And that will be the correct value for, or correct expression for squaring x plus 2. Let's do that again with another example here. So using this shortcut, we could square the first term. So we got 3x. If I square that, that's going to give me 9x squared. Go ahead and do the last term here. So squaring a negative 5 will give us a positive 25. To get our middle term, I need to take this 3x and this negative 5, multiply it by 2 and by each other. So 2 times 3x times negative 5. All right, so it's definitely going to be a negative answer. I got 2 positives and a negative, so we're going to get a negative. I'm going to go ahead and multiply 2 times 3 times 5. That's going to give me 30 and x. So 9x squared minus 30x plus 25. This works even with more complicated binomials. In this binomial, we actually have a square root. We'll follow the same process that we did a minute ago, though. We'll take this 5, we'll square it. That's going to give us 25. We're going to take this square root, and we'll square it. Now, first of all, it's a negative, but when I square it, it's going to turn into a positive, because a negative times a negative is always a positive. And when I square a radical, the radical goes away. Squares and radicals cancel each other out, so we'll just have a 2 minus x rather than a radical 2 minus x. For my middle term, I need to multiply my first term times my second term and times 2. So 2 times my first term times my second term, which is going to get me a negative answer, because I got a positive times a negative. 2 times 5 is 10. And we're still going to have a radical 2 minus x in there. Now that's pretty messy, but that is the expression we get if we were to square that binomial. Note that you could combine this 2 and this 25 together to get 27. Okay, now why are we doing this? Well, because these are going to come up a lot as we start solving equations with radicals. Basic steps for solving equations with radicals. Our goal is to get rid of the radical. Okay, first step, we're always going to isolate the radical first. This is very important. You have to get the radical alone on one side. Now, if you have more than one radical, just pick one of them and get it by itself. Everything else on the other side. All right, step 2. We are going to square both sides of the equation. We're going to put parentheses around both sides of the equation, and we're going to square both sides. Not just the terms, but the actual side itself, and that's where we're going to use our shortcut. Now, here's the deal. That's going to get rid of one of your radicals. Now, if you only have one radical to start with, then you will have no more radicals left. You can go ahead and solve it and check for extraneous solutions. We'll come back and talk about that last step in a minute. Now, if after this second step here you had another radical still, you would need to return to the first step. You would need to isolate that radical, and then go ahead and square both sides again, and that should eliminate another radical. Now you may still have radicals left, in which case you would need to go back and do step 1 and 2 again and again and again until you don't have any more radicals. Now, mostly in this course you're only going to see equations with 2 radicals in them at most, so you'll only have to repeat those 2 steps 2 times. All right, let's talk about extraneous solutions. This is very important that we do. A lot of times when we're solving equations with radicals, we're going to do everything right, but we're going to end up with answers that do not work in our original equation, and that's just the nature of these types of equations. It's very important that when we get done, if we come up with any answers at all, that we check each of those answers back in the original equation, the one from before you even started step 1 here, back in the original equation, and if it doesn't work in that equation, we have to toss it out. It's very important you remember to do this because this comes up quite a bit in these types of problems. Okay, let's go ahead and work through some examples here. These first 2 examples are relatively simple. If you remember, our first step is to isolate the radical, get it by itself on one side of the equation. Now, in our first equation, that's already done for us, so we can go ahead and move on. The second step was to square both sides of the equation. Now, I'm always going to draw parentheses around the entire side and square the entire side. If we do that, in this case, we are going to get 81 on the left, and the square will cancel with the radical. We'll get k over 2 on the right. All right, one more quick step of algebra. We'll get rid of that 2 in that equation. We'll multiply by 2 on both sides, and we'll get our final answer. Actually, not our final answer, because we do need to check and make sure that it works in the original equation. Okay, so let's go back to our original equation and make sure that this answer does work. Our original equation was 9 is equal to the square root of k. Now we think it's 162, and then divided by 2. Let's check and make sure that this works. Simplifying on the inside of the radical, 162 over 2 is 81, and the square root of 81 is indeed 9, so that checks out. Our solution to this equation is just going to have one solution, and that is going to be 162. Great. Moving on to our second equation here. Again, first step is to always get one radical on the one side by itself, and that has been done for us already. Second step, go ahead and square both sides. On the left-hand side, we're going to get a 100. On the right-hand side, the square is going to cancel with the radical. I'm going to get 1 minus 11a, and we've eliminated the radical, which is our major goal in solving these things. We need to do a couple steps of algebra to finish this up. Let's start by subtracting 1 from both sides. That will give us 99 equal to just negative 11a. Ones are gone. Then we'll divide by negative 11 on both sides, which will leave us with just an a over here. 99 divided by negative 11 would be negative 9. So we think that our answer is negative 9, but I'm going to go back to our original equation, check and make sure that works. So 10 equals the square root of 1 minus 11 times a, and we think that a is 9. All right, so this is going to give us 10 is equal to, that's a negative 9 there. All right, so 10 is equal to 1. I got a negative times a negative. That's going to turn into a positive. 11 times 9 is 99. And one final step here, 10 equals the square root. 1 plus 99 is 100. And 10 is equal to the square root of 100, so that works. So our solution set in this case is just going to be negative 9. Okay, we're going to move on to a couple more difficult equations. In the first of these, we do see that we do not have the radical by itself at the beginning of the problem. So our first step, as you can see on the right here, is to isolate the radical. We'll start by getting the radical alone. I just want to get rid of this negative x here, so we'll add x to both sides. And on the left-hand side, I'm going to write this as x plus 2, but 2 plus x would be the exact same thing. And now we have the radical isolated. It's by itself on one side of the equation. In my next step, I am going to square both sides. Let me rewrite this. Now, when we square both sides, we need to square both sides. It is not correct to just square everything in the equation. We need to square both sides, meaning I'm squaring not the x and the 2, but the entire x plus 2. This is where we're going to use our shortcut we talked about earlier. Square the first, square the second, multiply 2 times the first times the second, which would give us a 4x here. On the right-hand side, when we square that radical, it's just going to make the radical disappear. Okay, from here we can go ahead and solve. Now this is a quadratic equation. I know because it has an x squared in it, so I want to get a 0 on one side of the equation first. So let's start by getting a 0 over here. Let's get rid of this 2x and this 3 by subtracting both from both sides. Now I've got x squared plus 2x plus 1 equal to 0. We can either try and factor or use the quadratic formula. I always try to factor first because I find that easier. And this does factor into x plus 1 times x plus 1. Now we can set both of our equations equal to 0, or both of our factors equal to 0 rather. And they are the same. So x plus 1 equals 0, x plus 1 equals 0. Let's just solve one of them. Subtracting 1 from both sides is going to get us x equals negative 1. So we think that our solution is x equals negative 1. However, it's very important that we check to make sure that that is a solution and not an extraneous solution. So we're going to go back to our original equation and check and make sure that this works. So my original equation was 2 equals the square root of 2 times x, which I think is negative 1, plus 3, and then outside of the radical, minus x, which was negative 1. Let's check and make sure that this holds up before we write down our final answer. So 2 equals negative 2 plus 3, minus negative 1 would be a plus 1 on the outside. 2 equals the square root of negative 2 plus 3 is 1, plus 1. The square root of 1 is 1. And 2 is equal to 1 plus 1, so I think it checks out here. So our final answer, our final solution set is going to have a single solution, which is negative 1. Let's look at another moderately difficult problem. Again, this one has a radical in it, only one radical. And that radical is not by itself at the beginning. So our first step is going to be to isolate the radical. So let's subtract 3 from both sides. That'll get the radical by itself. Now I have an x minus 3 and just the radical over on the other side. Okay, next we're going to go ahead and square both sides. That should get rid of that radical. It's important that we square both sides and not just every term in the equation. Don't forget to put parentheses around both sides. And when we square x plus 3 or x minus 3, we're going to need to use our shortcut. So that's going to be x squared. Squaring the negative 3 will give us a plus 9, and then our middle term is going to be 2 times x times negative 3, or negative 6x. Over here, when I square that radical is just going to disappear. Okay, now we need to solve this again. We have a quadratic, so I need to get a 0 on one side first. Let's go ahead and subtract 6x from both sides. Let's add 27 to both sides. Those will cancel. We've got x squared minus 12x plus 36 equal to 0. All right, let's try to factor this. See if it will hopefully factor for us. I think we can get x minus 3. Nope. Here, 36, 18, and 2, no. How about, let's see, I'm having a hard time with this one. What about, how about 6 and 6? X minus 6, x minus 6. All right. Don't know why that took me so long, but we got there. Okay, now we're going to set each of our factors equal to 0. Now, it's kind of strange if both of these problems ended up having two identical factors. That's not always going to happen. All right, so we're going to get two of the same answers. We're going to get x equals 6. Now, it's important, again, that we go back and we check and make sure that this answer makes sense in our original equation before we did anything to it. So, scrolling back up so I can see my original equation. We've got x equals, now x we think is 6, and then square root of 6 times x, again, which we think is 6, minus 27, and then outside the radical we've got a plus 3. Let's check this and make sure that it works. So 6 equals, 6 times 6 is 36, minus 27 plus 3. 36 minus 27 is 9, and the square root of 9 is 3. And 6 is definitely equal to 3 plus 3. So we are going to keep it. We are going to keep it. So our solution set will be just 6. Okay, let's look back to this problem because this one was kind of a big one. First thing we did was we isolated the radical. We got that radical by itself here. Second thing we did was squared both sides. That got rid of our radical for us. We had to do some work to solve our equation, including some factoring. And we made sure at the end to check to make sure that our solution was not an extraneous solution. Our solution checked out, so we kept it. All right, moving on. This one's a little bit more complicated because it does have two radicals in it. So we're going to start this off by first isolating one of the radicals. Now, note that this radical is already isolated, so we don't really need to do anything in this step. I'm going to go ahead and copy it down again. I'm just going to say that that radical on the right-hand side is already by itself, and so this step is taken care of. So really, what we need to do first is to square both sides. So we've isolated the radical, or it was already isolated for us. Now we need to square both sides. Now this looks like it's going to be a little bit complicated, so we'll take our time and make sure we do this correctly. All right, we need to square the first term. Squaring a negative 1 is going to give us a positive 1. And then I need to add 2 times the first term times the second term. So in my head I'm thinking 2 times negative 1 times the square root of 9 minus 7x. Now 2 times negative 1 is negative 2, and then we're going to have that radical tacked on at the end here. Okay, finally we need to square the second term. So I'm squaring this 9, or the square root of 9 minus 7x. Now when I square that, that's going to cancel the radical. I'm just going to be left with 9 minus 7x. On the right-hand side, we only have one thing to square, and it's got a radical over top of it. The radical will cancel this with the square. We're going to have not 4 minus 5x here. Okay, because we still have a radical in our equation, we need to go back and repeat these first two steps. So I need to go back again and isolate the radical. I need to go back again and square both sides before we solve. So I'm going to start by getting the radical by itself here. I want to get this 9 minus 7x by itself. So let's do a little bit of subtraction on both sides. Let's get rid of the 1 and the 9. Let's get rid of that negative 7x by adding 7x to both sides. And let's see where that gets us in our next step. That's going to get us a negative 2 square root of 9 minus 7x equal to 4 minus 1 minus 9 is going to get us negative 6. And then negative 5x plus 7x is going to get us positive 2x. All right, in this case, we're going to go ahead and divide through by negative 2. Now, it turns out that you don't have to do this. And actually, I'm going to go ahead and work it out without actually dividing by the negative 2 here, and moving on to the next step, which is to square both sides. So the step says to isolate the radical here, but it turns out that if you just have a coefficient on there, you can get away with just squaring both sides. And I'll show you what I mean here. So let's say we just leave that negative 2 on here. and I square both sides. Now when I square something like this, I have to square both the outside of the radical, so I'm squaring that -2 to get 4, and I need to square the radical itself. Now when I square that radical, the radical is going to cancel, so I'm going to get 9 minus 7x. I'm putting that inside of parentheses because the 4 is multiplying by the whole thing, not just the first step. Okay, on the other side, we're going to need to use our shortcut here again. Square the first term, -6, when we multiply it by itself will give us a positive 36. 2x, when I square that, that's going to give me a 4 and an x squared. And then 2 times -6 times 2x is going to give me -24x. All right, from here we just need to solve. I'm going to go ahead and distribute on the left-hand side. We've got 36 minus 28x. And I am going to get a 0 on one side because we do have a quadratic here. So let's subtract 36 from both sides. Let's add 28 to both sides. And those will cancel, giving us a 0 over here. 36 minus 36 is going to cancel. I've got a -24 plus 28 is going to give us a 4x. And then we've got a 4x squared also. Okay, moving right along. Let's go ahead and pull out a GCF here. It's going to leave us with 1 plus x inside. And now that we have it factored and 0 on one side, we can go ahead and split up our two factors, setting them each equal to 0. Solving this one, divide by 4 on both sides, you're going to get x equals 0 divided by 4, which is 0. Solving this one, we'd subtract 1 from both sides, we've got x equals -1. So we've come up with two solutions, x equals 0 and x equals -1. We definitely want to check this and make sure that those are actual solutions and not extraneous. Let me scroll back up here and copy our original equation, bring it down so that we can see it. So these are supposed solutions. We are going to check these in the original equation and make sure that both of them work. All right, let's start with 0. So plugging 0 in to this equation is going to give us -1 plus the square root of 9 minus 7 times 0 equals the square root of 4 minus 5 times 0. Let's simplify that. 7 times 0 is just 0, so that's going to be 9 minus 0, which is still just a 9. Same thing over here, -5 times 0 is going to be 0, so 4 minus 0 is still a 4. Keep going here, -1 plus the square root of 9 is 3, equals the square root of 4 is 2. And that is a true statement, so we're going to keep it. So x equals 0 checks out. Let's go back and check our second supposed solution. X equals -1. So I've got a -1 plus the square root, okay, 9 minus 7 times -1 equals 4 minus 5 times x, which we think is -1. So -1 plus the square root of 9, that's going to be a plus 7. And that's going to be 4, and that's going to be a plus 5. -1 plus the square root of 16 equals the square root of 9. The square root of 16 is 4. Square root of 9 is 3, and that one checks out as well. So this one has two solutions. Both of them check out, 0 and -1. Okay, one last example here. This one's also going to have two radicals in it, so this is going to be another doozy of a problem here. So again, we're going to start by isolating one of the radicals, but that is already done for us in the first step. So we're going straight on to squaring both sides. All right, so putting parentheses around each side and squaring, we're going to see, let's see here, using our shortcut, square the first term will give us a +4, square the last term, and even though that's a negative radical, when I multiply it by itself, it is going to turn into a plus. And the radical will cancel because of the square, giving us 2x minus 1 on the inside. Now, for a middle term, we need to multiply 2 times the first term times the second term. Notice that we have a negative here and here. Those are going to cancel, leaving us with a plus. 2 times 2 is 4, and then we have to have this radical in here as well, 2x minus 1. The right-hand side is going to be easier to square because it just contains a radical. The square will cancel with the radical, giving us 4x plus 5. Now, again, we have an equation that has a radical in it still, so we're going to need to isolate that radical. So let's start by getting rid of some stuff over here. Subtracting 4 from both sides, subtracting 2x from both sides, and adding 1 to both sides. So we're going to get some canceling going on here, leaving us with 4 times our radical on the left-hand side. Right-hand side, we've got a 2x and positive 2. Okay, now again, we could divide through by this 4 that's out in front. Notice if we did that, we would end up with some fractions over here, and I really don't want to deal with fractions, especially in these types of problems. So I'm going to leave the 4 there, and just remember that when I square both sides, since those are multiplying together, it's going to be okay to just square this thing and square this thing. Okay, that's okay if they're multiplying together. We cannot do that over here because they're adding together. All right, let's deal with the left-hand side first. Squaring the 4 is going to get us a 16. Squaring the 2x minus 1 under the radical is going to cancel the radical. It's still going to leave us a 2x minus 1, but they should be grouped together, which is why I'm using parentheses. Right-hand side, use your shortcut. Square the first, square the second, multiply 2 times the first times the second. That's going to get us an 8x. All right, now we just need to go through and solve. Again, this is a quadratic, so we're going to want to get a 0 on one side. Let's distribute the 16 first. Let's get a 0 on one side, so I'm going to be subtracting 32 from both sides, 32x that is. I'm going to be adding 16 to both sides. Those should cancel. It's going to leave us with a 0 over here. Okay, we're going to want to factor this one. I'm going to start by pulling out a GCF. I'm not sure if it's going to factor after that, but at least we'll be dealing with some smaller numbers if we do have to use the quadratic formula. All right, and let's go ahead and try and factor this, leaving the 4 out in front. This would be x minus 1, x minus 5. So it does factor. We can go ahead and take each of our factors, set them equal to 0, and solve. So 4 equals 0. We got x minus 1 equal to 0, and x minus 5 equal to 0. Now, we can't solve 4 equals 0 because, well, there's no variable to solve for, and it's not a true statement, so we'll just ignore that. Adding 1 to both sides here is going to get us x equal to 1. Adding 5 to both sides is going to get us x equal to 5. So we think we have two solutions, x equals 1 and x equals 5. We do need to check and make sure that they both work. So let me pull down our original equation. And we can plug these in and make sure that they do work. So starting with our first equation here, or sorry, our first solution, x equals 1. All right, so let's simplify. 2 times 1 is 2, minus 1 would be 1. 4 times 1 is 4, plus 5 would be 9. This equation says that negative 2 minus the square root of 1 is 1. Square root of 9 is 3. Negative 2 times minus 1 is equal to 3. Now that is not a true statement. It's not a true statement. So we are going to need to eliminate that solution. That would be an extraneous solution. All right. Let's go back and check our second solution, which was 5. All right, so simplifying. 2 times 5 is 10, minus 1 is 9. 4 times 5 is 20, plus 5 is 25. All right, negative 2 minus square root of 9 is 3. Square root of 25 is 5. This equation says that negative 2 minus 3 is equal to 5. That's not a true statement either. So we have to eliminate that solution as well. Okay, well, if we've eliminated both of our solutions, then this equation does not have a solution. I can write for my answer the words no solution. Or you could give your answer as the empty set, which looks like a 0 with a line drawn through it at a diagonal. Okay, that's a lot of work to do for no solution, but that's how they come out sometimes. It is very important that you do check at the end to make sure that your answers are not extraneous solutions. When you are graded, if you give answers that are extraneous solutions, that will be counted wrong. All right, so today we talked about how to solve equations with radicals. The big thing here is to get rid of the radicals. So we're trying to get rid of the radicals. We do that using the operation of squaring on both sides. It's important that before you start squaring both sides, you always isolate the radical first. In the second step, when you do square both sides, make sure you're putting parentheses around both sides and squaring both sides and not just the individual terms. And it's very important that at the end of all of these problems, you go back and check and make sure that your answers work in the original equation. Otherwise, you need to eliminate them. Thank you so much for your attention. Have a good day.